Welcome back, and today I've got a fun experiment to show you. We're going to be looking at how heat travels through metals. Now, there's something really rather strange that you might not have noticed or at least taken on board when you pick up objects. This pair of scissors has been in my room all day and all night, so it's at the same temperature as the room, it's in thermal equilibrium, and if I hold the handles, which are made of plastic, they actually feel different from the metal, which if I grip it tightly feels really quite cold. If you pick up a large lump of metal like this engineering nut, it feels really cold, even though it must be at room temperature. So why do metals feel colder than things like plastics or wood? Now, the reason for this is that plastics and wood are bad conductors of heat, and metals are really good conductors of heat. They take the heat out of your hand much more quickly than a plastic would. So I've got a nice experiment to show you to demonstrate this. So, if metals are good conductors of heat, let's take 4 different metals and see which is the best one. So I've got a ring here, and on it are 4 different metals. That's aluminium, copper, that's iron, and that's brass. And we're going to heat them and see which one conducts heat the best. The way to do this experiment is to take the ring with the 4 metals on, and I've got some little aluminium rivets here, and I'm going to put a tiny bit of Vaseline on each one, and then I'll glue it onto the end of each of the metals, and then we'll heat them up and see what happens. So I've got 3 of them on. Let's just put the last rivet on. So a little bit of Vaseline, it's all very sticky, and we can then glue that one on to the brass, and we're ready to do the heating. So let's put this on the tripod, and what we do is we turn it upside down, so when it's heated up the rivets will fall off, and I'm being careful to make sure that each of the rivets is overhanging the edge, and we'll turn the Bunsen on and see what happens. So let's light the Bunsen, go for a roaring flame, and put the Bunsen right under the middle of the apparatus and see which one goes first. So it only takes a few moments, and the heat will be travelling down each metal bar, and then when it gets to the end, if it gets hot enough, there we go, that's the first one, that's aluminium, that's copper gone. We have to wait a little bit longer whilst heat travels down the other ones. Clearly it's conducting a bit more slowly, and it's interesting that the aluminium and copper go quite quickly. The iron's still hanging on and taking quite a while, and the brass is still on there. I can see the Vaseline beginning to melt, but it takes quite a bit longer. So the heat's travelling down the brass, there we go, a little bit more slowly than the copper, and we're getting smoke, that's from the Vaseline burning off, but the iron bar still hasn't gone. We'll leave it, I was going to say, leave it for a little bit longer and I'm sure it will go. So I'll turn off the Bunsen, move it out of the way, and one of the things that's interesting is I can pick up this from the wooden ring because the wood's a bad conductor of heat. So what we'll do, look at which ones went first, and we'll try and explain what happened. So, time for a bit of an explanation. We noticed that the metals didn't conduct heat at the same rate. I think the aluminium and copper went very quickly, the brass took a bit longer, and the iron took even longer. So, metals don't all conduct heat at the same rate. Now, we know that conduction is caused by the vibration of atoms passing on vibrations to the next atom, but metals are a little bit more interesting. You'll notice that metals also conduct electricity very well, and they've got free electrons in their structure. And the metals that conduct heat the best are the ones that have got the most free electrons. So aluminium has clearly got a large number of free electrons and will conduct heat well. Copper's also very good, and it's a very good electrical conductor. Brass actually contains copper, it's an alloy. And iron has less free electrons in its structure, so that doesn't conduct heat quite as well. So what we've seen there is different metals, even though they conduct heat, don't conduct heat as well as each other. Now, there's one thing I really must say with this apparatus, which it shows very, very well, especially if you're doing exams in science. It's really important this is a fair test. So we've changed one variable, we've changed the type of metal, but we must use the same heat source, we must use the same thickness of metal, we must use the same width and the same length of metal, and we must heat them all at the same place and use the same mass of little rivets stuck on, and if we can, the same amount of Vaseline. So we're only changing one variable. If you think about this, there are so many different things we could change, but if we want to see which metal conducts heat best, we have to keep everything the same apart from the type of metal. So you've now learnt a little bit about conduction and why the scissors feel cold on the metal and a bit warmer on the handle. Plastics don't contain free electrons, so don't conduct heat well, so leave the heat in your hand. And metals do have free electrons in them, conduct really well, and so take the heat out of your hand quite easily and therefore make you feel colder, and therefore the metal feels colder. So, I hope you enjoyed that experiment. I'll be doing another one soon, and I look forward to seeing you then.